An experiment on photoelectric effect was carried out to investigate the maximum kinetic energy of the electrons emitted from the metal surface when light of various frequencies are shown on that particular metal surface. Here are the results. Frequency of the incident light, the kinetic energy of the emitted electrons. We are going to plot a graph of kinetic energy against frequency, and we will use that particular graph to find the threshold frequency. Second, we will find the wavelength. Third, we will find the work function of the metal. And the fourth one, we will find the value of the Planck's constant. Here are the points plotted on a pair of axes. Kinetic energy of the electrons against the frequency of the incident light. We are going to draw a line of best fit. We will use this particular graph to work out the wavelength. The threshold wavelength is going to be the cutoff frequency required for that electron to get ejected from the metal surface. And as such, the threshold frequency is going to be the place where the line cuts the x-axis. And as such, the answer is going to be 4 times 10 to the power 14 hertz. For the second one, to find the threshold wavelength, we all know that the speed of light is given as 3 times 10 to the power 8 meters per second. Therefore, the wavelength is going to be the speed divided by the cutoff frequency, and as such, it's going to be 3 times 10 to the power 8 divided by 4 times 10 to the power 14. The answer which you are going to get is going to be 7.5 times 10 to the power -7 meters. This is the threshold wavelength. The third thing, we are going to find the work function of the metal. In order to find the work function of the metal, we will calculate this graph. Upon extrapolating that graph, we notice that the line cuts the y-axis at about 2.4. So it's going to be 2.4 times 10 to the power -19 joules. That is going to be the work function, the minimum energy required for the electron to leave the metal surface. The fourth value which we are going to find is going to be the Planck's constant. In order to find the Planck's constant, we will find the gradient of the line. To find the gradient of the line, we will locate 2 points on the graph. We locate 2 points on the graph, and as such, it is going to be 4.7 minus 0.7 divided by 11.9 minus 5.4 times 10 to the power 14. Upon doing the calculation, we get the answer as 6.15 times 10 to the power -34 joules second. This is the value of Planck's constant. A generalization one can draw. Given the linear graph, we all can say that energy is equal to HF minus epsilon naught, where H is the gradient and epsilon naught is the work function.